This is section 9.1, matrix solutions to linear systems. So we were dealing with linear systems in 8.1, and now we're going to see how we can incorporate the matrix that we just talked about in 9.3. So just reviewing about our matrices that we had discussed. When we talk about the order of a matrix, we're just talking about the dimensions. So we always describe the dimensions rows by columns. So this would be a 3 by 2. And when we talk about the elements in a matrix, we're just talking about the separate values that are given in just this like table of numbers. So if we say element A21, we're describing the value that's in second row, first column. So the 2 is the row and the 1 is the column. So second row, first column, so 2. Okay, so when we're dealing with systems of equations, we can enter these into a matrix, but we have to make sure that our columns are accounted for with X, Y, and Z, or whatever variables are used, and then the constant. So I'm going to reorder this so that it reflects separate columns. So 7x minus 5y plus 6z equals -8. That first one has all three variables, but this one only has x and y, and then the last one only has x and z, and then all of them have that constant though, right? So when I go to write this in, I'm going to write in the coefficients. So here, that would be 1 for for z, since I don't have one, it would be 0, right? And then same thing here for y, it would be like 0. So I'm only writing in my coefficients, 7, -5, 6, -8 for that top row. Second row, 1, -5, 0, 5, and then last row, 4, 0, -8, and -1. So it's completely direct like that. Whatever you see for those coefficients, you're just going to copy them into the matrix. Again, I would make sure that I just account for everything being lined up correctly. And then my constants are over here. Because if I would have just done it how it was originally given to me, then I could have mistaken these for zeros. And that's not the case because my x's would have been lined up underneath that. All right, so notice that now this one has 5 columns, and that means that we have another variable in the mix, so we have a w. So now we're going to go the opposite direction. In that last problem, we went from the system of equations to the matrix, and now we're going to go from the matrix to a system of equations. So 1w minus 3x plus 4y plus 5z equals 8. And then there's 0 for w, so nothing for w. 1x plus 5y, nothing for z, equals 17. Third row, nothing for w, nothing for x. We have 1y minus 1z equals 3. And then for that last row, just w and x coefficient, and then that constant. So this is our system of linear equations. Just being able to translate that back and forth. So now that we know how to enter a system of equations into the calculator, we're going to show how we can solve these a lot easier than before. So remember in 8.1 we used the substitution method. We also use the addition method, right? After you see this, you're gonna be like, oh, okay, this is so much easier. If you ask for help on these questions in my math lab, it is going to take you through a very long process. And so I'm just gonna briefly talk about this. The process that they will take you through is that they will have you start to manipulate the matrix and augment it so that you have it set up where it shows you what x equals, what y equals, and what z equals, okay? And when you get that, you'll have something like this. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then there'll be values here. Okay, so this would be like 1x equals a value, 1y equals a value, and 1z equals a value, right? So that's where it will try to take you eventually at the end. But it does that through different steps, almost like a Rubik's Cube. It has you start eliminating the values in different rows. And so that's what this problem right here is trying to show you. It's saying, okay, let's multiply row 1 by -2. So that the entire row, that would be -2 minus 4 plus 14 plus 10. Sorry, I didn't have to write the plus. And then add that to row 2 to get the new row 2. And that step was only to get 0 in the first part of row 2, right? So can you imagine trying to continuously do that more and more and more so that you can get that setup of 1x equals blank, 1y equals blank, and 1z. So let's see the quicker way to do that. But just warning you, if you go into my math labs and ask for help, it will take you that route. So first, let's just look back at how we solved this by hand. So x plus y equals 7, and then 2x minus y equals 11. We're going to use the substitution method here. Or actually, sorry, we're using the elimination method here. So you can't use the substitution method. I could solve one of these for x or y and plug it in, but because we have this, it makes sense that we would use the addition method, also known as the elimination method, because they're automatically going to eliminate when I add these two equations together. So I add the two equations together, I get 3x equals 18. I solve for x, and I get x equals 6. Once I get 6, I plug it back into one of the original equations, and then I solve for y, and I get y equals 1. So my solution is 6, 1, right? That works, not so bad, but remember, once we get like a third or even a fourth variable into the mix, it can get very, very tricky, right? So let's go ahead and see how we would do this. Okay, so that's that work I was showing you before, how we would do this by hand to try to get down to this. Because look, if I did all of these augmentations, then I would end up with 1x equals 6 and 1y equals 1. And that was our solution before, right? So let's see how we do this in the calculator. Let's go ahead and get our matrix out. So F3 for matrix, I need a 2 by 3. So we're only going to use one matrix. And actually, before we go to the calculator, let's go ahead and write this out as a matrix. So 1, 1, 7, 2, -1, 11. So 2 by 3. Check my numbers. Okay, looks good. Exit out. I'm only using this one matrix. So now from the main screen, I'm going to press Option, then F2 for matrix. So notice I'm not choosing matrix from the main screen. I have to press option first. If I press matrix from the main screen, it's going to take me where I just was a second ago, where I can enter in my different matrices, right? So F2, then F6 to get more options. And then you want to go for RREF, not just ref, but RREF. So F5, okay? That is what you need to enter in first before you enter in which matrix you're having it solve. So that is the command that's telling it, okay, go ahead and tell me what X and Y is. So shift matrix, shift 2 for matrix, then alpha A, and voila. So it gives us that. And remember that first column, so let me go back to this screen. So this is what it gives me, right? And remember this first column is my Y's, my X's, and then this was my constant. So I have 1X equals 6, 1Y equals 1. And indeed, we said that our solution was 6, 1. So much easier than actually trying to do the math. This problem wasn't that bad, but the ones that we're going to get to, you'll see that you'll much rather take this approach. Okay, so here we go. I'm not going to enter it. I'm going to pause it real quick and then enter it, so we just bring it up, but this is what we're going to see on the calculator. Let's take this first. And I actually like to write it out exactly what I'm going to enter, so I'm not trying to think about, oh wait, which column would have what. So 1, 1, 1, 4, 1, negative 1, negative 1, 4, 1, negative 1, positive 1, 0. Okay. F3 to actually get to that matrix. And then we need a 3 by 4. Okay, got it entered in there. So I'm going to exit out all the way to this screen, right? Press option first, then F2 for matrix, F6 for more options, and then F5 for RREF. Shift 2 for matrix, alpha A, because that's the matrix that I have it entered in for. Oh, I need to get matrix in there. There we go. And voila. So again, look at this. It shows 1x equals 4, 1y equals 2, and 1z equals negative 2. So 4, 2, negative 2. Oh, they have a place for it right here. 4, 2, and negative 2 is my solution set. Okay, so they want us to solve the system using matrices. It tells us if there is no solution or if there are infinitely many solutions. And a system's equations are dependent, state this. So they give us that option. We'll talk about that here in a second. But for now, let's look at how we would notate this in a matrix. So this is what I'm going to enter in. 1x, 2y, 0, z equals 0. 1x, 3y, 1z equals 1. Negative 4x, negative 1y, negative 1z equals negative 25. Okay, take it to our calculator. Let's exit out of this. And I need a 3 by 4. Since that's already the dimensions there, I'm just going to press execute, and now I'm going to enter it in. Okay, got it entered in. That's why I feel like it's helpful to write it out first, because trying to think through this might confuse you a little bit. Exit out. And then I'm just going to delete this. So option, F2 for matrix, then F6, RF, F5, and then matrix A. So I had RF matrix A before. I could have arrowed back up there and pressed enter, and it would have given me the updated output. And there we go. So 6, -3, 4. So notice now we have a W in the mix. So instead of XYZ, we're solving for WXYZ. Same concept. So let's write it out in a matrix. That first row, I have 1W plus 1X minus 1Y plus 1Z equals -1. 2W plus 3X plus 2y minus 2z equals -21. 3w plus 1x minus 1y. I'm just reading this over from the system. Minus 1z equals -15. And then -1y, or w, excuse me, plus 2x plus 2y minus 2z equals -12. Enter it into our calculator. Again, to get to that, let's exit out of all this. Okay, F3 for matrix. We have, notice now, we have 4 rows by 5 columns. So be careful that you don't get mixed up with the number of variables with the columns, because you'll have always one more column than the number of variables because you have that column for your constants on the right side of the equation. So I have 4 by 5. And let's enter it in. Okay, got it all entered in. Exit out. Option. F2 for matrix. F6 for more options. And then F5 for RF. Hopefully by now it's becoming a little bit more familiar. Write it down. Just write it down and just, keep going through the steps. All right. So we have 1W equals -2. 1x equals -3, 1y equals 1, and 1z equals 5. So -2, -3, 1, 5. Before we get to these two last ones, let's talk a little bit about what we would see if there was infinitely many solutions or the solution set is empty. So if I get to anything and I have a row like this with all zeros along it, then that would mean that I have infinitely many solutions, okay? Because remember, there's a true statement here. I don't have it's not the same as like, oh, z is equal to 0, right? No, it's saying there's 0 on the left side and 0 on the right side. So in the past, we saw that when we had a true statement, that meant there was infinitely many solutions. But then if I have a solution set that's a false statement, so let's say that I have a value here, so 0 equals 5, right? Then that's not going to work. And let me put the other zeros in there, because that means they're not saying like 1x, 1y, 1z, 1 or 1w or any of that equals 5. No, it's 0 in all of those, and on the other side there's 5, or vice versa. If I had, well, no, because that would be equal to 5. I'm sorry. So if we have this untrue statement, untrue, then it would be empty set. And then if we have this true statement, infinite many solutions. Okay. So it's exactly the same rules that we applied before, but now actually seeing it in the matrices. All right, a word problem. This chart can be a little bit confusing because you'll naturally want to set up your rows going across like the way the rows are here. But notice that in this first column, there's calories. In the second column, there's proteins. In the third column, it's vitamin C. And they're saying, okay, the total amount of calories has to be 1,200. So this whole thing added up would be 1,200. All the grams of protein have to be 54. And then all the vitamin C has to equal 2,500 milligrams. So they're allowing these 3 foods, but they say, look, the way that it has to match up, it has to be equivalent to this many calories total, this many grams of protein total, and this many milligrams of vitamin C. So they want to know how many ounces of food A, B, and C. Well, instead of setting it up like this, which a lot of people will try to do that, in your matrix, you're actually going to rearrange this a bit. So this is my first row. Food A, right, has 100 calories. Food B has 200 calories. Oops, that's supposed to be a B. Food C has 400 calories. And then it has to equal to 1,200. Okay, then our second row, food A has 8 grams of protein, and then food B, and I say food B, the ounces in food B, right? And then for C, and that all has to add up to 54. So obviously 8 plus 5 plus 12 don't add up to 54, but when I multiply it by how many of our ounces are in here, and then 5 by how many of our ounces are in of food B we have, and then 12 by however many ounces of food C we have, that has to equate to 54. And then same thing in the first row with the calories. So for vitamin C, however many ounces of food A we have, multiplied by 250 milligrams, and then 550 milligrams times however many ounces of food B, and then 400 times however many ounces of food C we have, has to equate to 2,500. So be careful, because this question can be very confusing to set up because of the way that the information is given. Okay, now I'm going to make my matrix. So 100, 200, 400, this is A, B, C, and that's my constant. 8, 5, 12, 54, 250, oops, 550, 400, and 2,500. Let's put this in the calculator. Okay, so we have everything entered into the calculator. We had a 3x4. Checking it. Okay, everything looks good. Let's exit out. And then option, matrix. Going a little bit quicker here because we've showed this quite a few times. So if you're still trying to figure out what to press, I'd go back to one of the previous problems. Something came out wrong. Oh, no, it didn't. Sorry. Okay. I was looking at the wrong thing. Okay, so we have 1A equals 4, 1B equals 2, and 1C equals 1. So 4 ounces of food A, 2 ounces of food B, and 1 ounce of food C. The setup is the most challenging portion of these word problems. Okay, let's look at this last one. So they want us to find the quadratic function, f of x equals ax squared plus bx plus c. So just like we were solving for a, b, and c in that last one, that's what we're solving for here. They're saying, look, go ahead and tell us what this quadratic function is. X is going to stay x, right? So we're able to plug in that value, but a, b, and c would have to be accounted for. So they give us f of 1 equals 13, f of negative 2 equals 7, and f of 2 equals 31. So what is the function? Well, for now, we're going to plug in x with the information given so that we can solve for a, b, and c. So when x is 1, then it would look like this. A times 1 squared. So notice that I'm just putting a 1 every place that there was an x, right? Plus c. And they're saying, look, when that happens, this will equal to, so on 1 squared, I'm going to simplify this, would just be 1a, right? 1 times b would just be 1b. And then there's not a x by that c, but that's just understood that it's a 1c equals 13. So f of 1 equals 13. That's where I got the 13. Okay? I'm going to grab a different color. So f of negative 2, a times 7 squared. Oh, not 7. Putting in a 2 everywhere here. So negative 2. Negative 2 squared plus b times negative 2, and then plus c, because there's no x by c, right? That coefficient's going to stay 1. So let's simplify this. So negative 2 squared is 4a, and then negative b times negative 2 is negative 2b plus just plain old c, right? But there's a 1 there. And we said when we have f of negative 2, we come out to 7. So far, these are our 2 equations in our system. All right, and then f of 2 plugging in a 2 everywhere there would be an x, and then plain old c. So simplifying 2 squared would be 4a plus b times 2 would be 2b, and then c is just 1c. And we said f of 2 equals 31. So there goes our system. Okay, so matrix would be, I'm focused on this first equation, 1, 1, 1, 13. Second equation, 4, negative 2, 1, 7. And then third equation, 4, positive 2, 1, 31. Aren't you glad that after we get those equations, we don't have to figure out by hand how to get the x to 1 with the other variables being 0, and then all that good stuff that they show you when you ask for help. So let's go ahead and put this in the calculator. Okay, I've got it entered into my calculator, checking my numbers just to make sure that everything's entered correctly. Exit out. There we go. X is 4. I'm sorry, A is 4. Because remember, this is not X, Y, Z. This is, oops, it entered it again. This is A, B, C. So A is 4, B is 6, and C is 3. So they're not asking though just for A, B, and C, right? And they're not asking to give it as like 4, 6, 3. They want it in the quadratic function. So in this box right here, I would write, not that, that's already given. But in that box right there, I'd write 4x squared plus 6x plus 3c. Oh, sorry, no c. Making up stuff there. C is 3. So 4x squared plus 6x plus 3. And that is your answer. That one's tricky too if you don't know how to get your equations.